Hello. Hello, guys. Are you guys able to hear me? Can anyone please chat in the window just beside the YouTube channel? Are you guys able to hear me? Great. Just let me share my screen. Just wait, guys. There's some problem with the screen sharing. Let it be loading. Are you guys able to see the screen PPT? Okay, just a minute. Now, can you guys please confirm? Okay. Now I guess it's working. Great. Okay. So let's start about the Kubernetes best practices. Okay, my name is Akash Agrawal, and thanks for joining today's webinar. So today we'll be talking about the Kubernetes best practices from the application developer's view. Of course, there is certain sections I'll be discussing from the administration point of view also, like cluster administrator, but our focus will be mostly on the application's view, application developer's view. Okay. So at this point, I'm guessing you guys understand about the basic architecture and the flow of Kubernetes very well. We also discussed these things in the previous meetups. So let's do a little bit recap, just 5 minutes about so that we can refresh the our previous discussions, and then we'll start the Kubernetes best practices. So in Kubernetes, what happens if you look onto cluster architecture, you have master nodes and you have worker nodes. Okay, master nodes is basically uh, takes care about the managing the cluster. So it has different components like Kubernetes API server, which basically works as exposing the Kubernetes APIs. Then you have a controller manager. So in Kubernetes, there are different kind of controllers like deployments, stateful sets, so on, which basically look after the scaling of pods, scaling of applications. Then you have a etcd, which is basically a database which holds the Kubernetes data, basically how many services you are deploying, how many deployments are there, and so on. Now, how the flow actually works in Kubernetes is one cluster administrator basically creates a cluster, a Kubernetes cluster. It may vary a very small cluster from 3 nodes to 5,000 node clusters, so on. So it may vary from very small cluster to a very big cluster. Now, what you do is first you create a container. Either you basically create the container on your local laptop by using the Docker commands, or you can basically configure a CI/CD pipelines also. You create the container image, you push it into a registry, and from the registry you pull the images and deploy it into cluster. Okay. So this is the how typical Kubernetes flow works. Now, if you talk about the Kubernetes best practices, you may divide this section in different sections. Like first thing is what is the best practices around the containers? How can I build the containers? What are the container internals I need to take care? Okay, this is just one section. Second thing comes is the Kubernetes best practices, like Kubernetes related with Kubernetes artifacts. Like what are the best practices around the pods? What are the best practices around the deployment as services? How can I manage secrets, configurations, so on? And third section comes is how to design the application on top of Kubernetes cluster. What are the things that I need to take care about the application design perspective or architecture perspective, or at least I need to consider. Okay. So we divided this presentation in three sections: container best practices, Kubernetes best practices, and application design architecture best practices. Okay. Just miss guys, let me check again the channel if you guys are able to see this thing. Okay, great. Okay, let's go forward. So first, look into container best practices. Okay, by the way, if you guys have any questions, just type it to a channel, chat channel just beside the YouTube video, and we'll discuss the question in last 5 minutes. Okay, after finishing the complete going through the PPTs. So let's look onto container best practices first, because container is something that contains your applications, and we deploy the containers in terms of pods in Kubernetes. The first best practice that comes is how to build the containers. What are the things that we need to be careful when you building the containers? Either it's part of your own, either you are building on your own laptop, just as a in the development environment or R&D or prototype way, or you are basically running as enterprise application through the CI/CD pipeline. So first and very important thing that you need to be careful about is container images must be small and secure. Now, why it needs to be small? See, you are building the container in your local laptop or CI/CD. It basically going through the build process. And think about the microservice environment, which is pretty common nowadays in enterprises. We have a lot of services around 100, 200 services, pretty common. And the frequent deployments are also possible, like daily and hourly, so on. In that cases, your build process, your DevOps process, pretty much important. And as if you keep your container images small, that will basically boost the performance of your CI/CD pipeline. It basically boosts the performance of your build process. Okay, so you can see there you can achieve the performance in three different sections: about the build time, about the pushing the images to the registry, and again in registry you are storing the images. So you are basically, if you are keeping the container images small, basically you are utilizing the registry space also. It's pretty well. Now pulling the container images and deployment in the Kubernetes cluster. Pulling the images is not only one time process. It may occur in multiple situations. So for example, you deployed you pull the container image and deploy it in as one pod into the Kubernetes cluster. Okay. Now some, because of some reason that node is not working, some hardware failure or something. So what Kubernetes will try to do is it will basically try to reschedule the pod into other node. And if you are mentioning like image pool policy as always, it always try to pull the images. Okay, the one reason is there are various sections where you need to basically pull the containers. One is about the cluster configuration changes. Other thing is like suppose you are scaling currently you are assume that you are running 10 pods currently. Okay, now you are scaling in because your traffic got dropped. In that cases it will try to reduce the container images or scaling out. Okay, so there are various sections possible where you need to pull the container image across the in the cluster, so it can basically boost a lot of performance on that. Second aspect is the security. So in general terms, not only in container, about any software, if you look onto any software perspective, short codes or basically compact codes are always best because they provide less attack surface area for vulnerabilities. You have a lot. If you go for larger softwares, okay, you should try to avoid as much as possible. So these are two major aspects where you need to be focused about the performance and security. Now, how you can achieve the container images as small container images? How you can maintain the container images as small? Whenever you create a Docker file in the container, the first line what you write is from statement, and then your base container image things. You should always focus on keeping it small. Let's take one example. Just go on to the hub.docker.com, search for node, okay, official image. Look onto the tags and just look on two tags. One is node 10 and node 10 alpine. Look onto the size difference. So node 10 basically comes with the 300 something, takes 300 MB space, and node 10 alpine it basically takes 20 MB something. It's a huge difference. Now it depends on your application. You need to ask yourself, do you really need node 10 or do you need compact version of node 10? There are a lot of serverless functionalities that came in nowadays into cloud native world. In the serverless world, if you'll see, you just write a function. Maybe for that function you don't require the complete node 10. Node 10 alpine is pretty much enough. So don't blindly just use any base images. Look for whatever two important aspects whenever you're choosing the base image. First is the size. Another thing is about the uh, try to scan the images through the some kind of vulnerability scanning tools. There are some open source tools are also available in the market. So for example, you go for core os, on that they provide the clear kind of clear open vulnerability scanning service. Okay, basically tool, so you can use that for checking the vulnerabilities. I'm not sure how much they are effective, but of course you can use that. And if you're in the cloud environments, most of the managed solution they provide vulnerability scaling, so that's great, always use it. Okay, so this is the one basic, the first aspect of keeping the container images small. Other thing is you can go for Docker best practices. So there are different Docker practices. So for example, when you run in the Docker file, when you use the run command, you should try avoid using the multiple run commands. If you can combine it, it's always great. Many times you do sudo like apt-get update plus apt-get install. It all these two commands are pretty much work together. So always try to combine them. So these are the few best practices related with building the containers. You always need to follow it. For more details, just search on Google Docker best practices and you can get the whole listing. What are the things you need to follow? Also try to use uh, authorized images. Try to avoid arbitrary images from the Docker Hub. You need to check who is the author. Okay, and if possible, always try to use private registry and push authorized images to that after scanning through the vulnerability scanning tools. Okay, you can also follow the builder pattern or multi-stage builds. So what it does is, suppose you are using Java or Go language uh, kind of programming language. In that, what happens? Let's take one example of Java only because it's more popular till that. So in Java, what you do is you write a Java file, then you basically compile it into .class file, and then run that class file into JRE environment, Java runtime environment. These are two-step process. In your container, you should always careful, always basically focus on the class files because you need a class files in the container. So what you can do is you can basically follow a multi-stage process, Docker multi-stage build. You will create a single Docker file, but there will be two stages. One stage will basically read the Java file and compile it into class file, and then second stage basically takes that class file and build the final container image. Just search for the Docker multi-stage builds on the Google, and you will be able to get more details. What is the impact of keeping the images small? Again, as I told you, look for the microservice environment, CI/CD pipelines, build frequencies. If you have a complex environment, you can basically save a lot of time of the build process or DevOps cycle. Let's go to the second aspect is about the container internals. So whenever you run any container or a pod, okay, you just try to log in on inside the container by kubectl exec -it and container name so on. You'll always get the root, okay, by default. Instead of that, try to run your container as a non-root environment. Okay. There are certain times when the container escape is possible. I mentioned a last link. I'll share this PPT anyway, so you guys can explore it. In the last, I added a URL. Just explore that. It's pretty much explained pretty well the scenario in which cases it's possible that your container is using root user, but it's basically escaped the container and came into host. So you should try to avoid that in terms of enterprises. Okay, it's just adding the extra layer of security. It's pretty important. So these two are major important points when it comes to the Kubernetes perspective, when you looking into how to build the containers and what are the container internals you need to be focused on. There again, when you go on to, so here I mentioned the security context as run as non-root. There are some other parameters also under the security context which you guys can explore. Okay. Now let's come on to Kubernetes. The first best practice around Kubernetes is you always need to basically organize your Kubernetes workloads, applications into a namespaces. So by default, whenever you create the cluster and you deploy a pod, it goes to a default namespace. But when you come onto enterprise applications, there are different project environments are possible: dev, QA, UAT, prod, so on. And the same service could be deployed on different environments. Okay, it's always best to organize your workloads into a namespaces. It basically provides three major important aspects. One is organizing workload. Suppose you are creating a services. If you have a namespace boundary, you can basically create same service with the same name on different namespaces. And you can, if you know about the kube DNS or how the DNS works, by default, whenever you call service to other service, it basically evaluate the URL as service.namespace.svc.cluster.local. Okay, so it basically using the namespace helps you to organizing the workloads. Second thing, it's helpful on the resource utilization. So whenever you use the namespace at that level, you can apply the resource quota policy, so on. Resource quota is again like resources are basically node resources, CPU, memory, and so on. You can define it at the pod level also, container level also, and namespace level also. So mostly namespace level, cluster administrator can basically specify at the namespace level, and developers can also define it at the pod level. The namespaces are pretty helpful on the resource utilization and security, of course. So there are different kind of RBAC access policies you can define at the namespace level, and that will help. So always try to use namespaces in your enterprise applications. Second aspect is checking the health checks. So by default, what happens whenever you run the pod, as the pod comes into running state, Kubernetes starts sending the traffic to that. There are many times, many instances when the application needs time to warm up. Maybe they are running some initialization scripts, maybe they are opening some ports, and so on. Okay. So it takes a while to basically start the pod a container. At that time, your container or pod is running, but your container is not ready. Your application is not ready to accept the traffic. So there are two major important things you need to be careful about: liveness probe and the readiness probe in respect to health checks. What it does is liveness probe is basically tells the system, Kubernetes system, that is your application is live or not, is your pod or container is running or not. And readiness probe basically defines is your container ready, is your application ready to accept the traffic or not. There are many times it's possible that your application or container is running, but they are not ready to accept the traffic because of some process which maybe initialization script or so on. So these are two very important aspects you need to define as part of your container or pod spec. Okay. So here there are three types of probes are possible in both liveness and readiness probe: HTTP, TCP, and command. HTTP means you are opening some port. Okay, system is heading on that port and it's giving 200 means success. Okay, status. In that cases, your application is good enough. When you go on to TCP, it comes to different port, or you can also execute some command and checks if your application is really ready to is live and ready to accept the traffic or not. You can also configure the probes through different parameters. I just mentioned initial three parameters, but there are more you guys can explore. So initial delay seconds, period seconds, and timeout seconds. I guess they are pretty much self-explanatory. You guys can look on. Third thing is resource request and limits. So you deployed a pod, you deployed an application inside a container and the pod. How much resources it's utilizing from the node, how much CPU it is utilizing, how much memory it is utilizing. You can specify it in the pod spec. Whenever you're creating a pod, as part of pod spec, you can define these parameters. And there are two major sections you define. One is in terms of request and one in terms of limits. Kind of you can think it of some min and max limits. Request means if you are allocating suppose 512 MB for particular application for particular container, that is a request dot 500 memory, request dot memory 512 MB. That is a minimum memory that is required for the application. So your Kubernetes application scheduler will schedule the pod only on that node which has that much of memory. Otherwise, it won't schedule. So this is kind of minimum requirement for application. Limits basically defines the higher limit. So fine, you define the 500 MB for the memory. But in certain cases, maybe in peak hours, maybe in the business hours, your memory utilization may go a little bit higher. Okay, so you want to provide a range. 512 MB is the minimum, but I want 1 GB something, or 7 or 800 MB space for the memory as a higher limit. So 500 to 800 is some kind of elastic nature. This is exact thing which comes under the limits. So request is kind of minimum, which is minimum is required for the scheduling, and the limit is like a higher limit. And this is both applied for the CPU and the memory. So you can define request.cpu, request.memory, limits, and limits.cpu, limit.memory. Okay. You can define it at two different levels. So as the application developer, mostly you will define it in the pod spec for each containers, but you can also define at the namespace level. I mentioned all the corresponding links if you are looking for the YML files and different configuration. You can just go through these links. You will get the sample files, configuration files. It's pretty much important for tuning your node and cluster resources both. When it comes to graceful termination of applications, so you created one application, okay? You basically created a container and deployed as a pod. You know, if you deployed the pod as part of deployment artifact, as the pod goes down, it Kubernetes systems starts it by own. So Kubernetes systems take care of starting the pod if it's not able to, he is able to see the differences on the expected and the actual. So you need to basically focus only on the termination, graceful termination of your application. Okay? There are two methods you can define. One is termination grace period seconds and pre-stop hook. Both are kind of alternative. Termination grace period seconds is pretty much enough, but in certain cases, maybe you require a pre-stop hook. So I've given some examples, like in the case of rolling update, in case of node draining. I already explained the node draining aspect before. Resource outage in the workloads. It is always required by the Kubernetes system. Suppose in a node your resources are out of like it's getting out, you are getting the outage of resource. In that cases, what resource manager will do, what the system will do, it will try to schedule the pod into other node. Okay, in that case it needs to terminate the pod and then start into other node. So that termination process is pretty much important. Your application should be able to gracefully terminate. That is most important aspects. You can explore the link up here. Now let's talk about the cluster environment. So this is till that whatever three or four aspects we discuss, it's pretty much important aspects and from the application developers view. But there are certain aspects from the cluster environment point of view. Mostly it's work of there are certain sections are basically responsibility of cluster administrator, but it's always good to know a little bit about that on from the application developer point of view also. Namespace we already defined, we already explained. RBAC is something kind role-based access control. So what happens? It basically improves the security of your inside your cluster. There are different kind of roles, role and boundaries, like cluster role and the normal role. Role is basically implemented at the namespace level, and cluster role is basically implemented at the cluster level. That can have multiple namespace. So you can basically create the roles inside that and assign it to the users. Third thing is resource quota and limit range. So we already defined the resources limitation, requests, and limits into pod level. But there are certain section, if you want to basically apply it the namespace level, you can use the request quota and the limit range. Request quota is mostly like applies at the common level, means it's like applied for the all the pods in the namespace, and limit range is specific to a specific pod, like default section. Then you have pod security policy and pod security context. Pod security context is basically part of your pod spec. So in the few slides before, we discussed about the run as non-root. Right? This is part of security context in the pod spec. So its lifecycle is pretty much connected with the pod. But pod security policy is complete Kubernetes resource, which is applied at the cluster level. Okay, but here also you can define the default. Okay, for example, your cluster administrator wants all the pods to be run as non-root. So he can define it at the pod security policy level, which is applied onto complete cluster instead of specific pods. And the network policy. Network policy is more like isolation at the network level. So suppose you are running the pods, different pods, and you want certain pods to be restricted from the accessible from the other pods. So let's take one example. You have a three-tier application. Your UI tier, you have server tier, you have database tier. You don't want your database to be accessible from the UI. You always want to go through the basically server level. So there are different networking requirements where you want some kind of ingress and egress rules to be applied for a specific pod access. That comes under the network policy. If you look from the microservice environment, there are some service meshes are possible which basically extend the same functionality. So for example, you guys have heard about the STO. So STO is a service mesh which is pretty much works awesome in terms of microservices. They provide various capabilities like your traffic splitting, provides like authorization, network level RBAC, network control, it provides the observability, so on. But if you are not using service mesh, of course, you guys can use this network policy. Secrets, it's we know always whatever is sensitive data, put it onto a secrets and just explore these options. Yeah, who has access to the secrets? Is it accessible? So for example, in the Kubernetes dashboard is also accessible. How many people can access the Kubernetes dashboard? Okay. So even either you are using secrets, okay, just pay some attention on the how the secrets are stored, how they are accessible, who can access that, and is there any expiry rotation and so on is been applied on that. It's whenever you try to design the system, whenever you try to create the application level things, you need to be careful about these aspects. Same way, so any Kubernetes API, if you want to access, if you want to create a deployment, if you create a pod, you go with the API server, you go with the APIs. That API is accessible outside of cluster by using the kubectl or Kubernetes dashboard or Kubernetes API directly. From the internal of the Kubernetes, also it's accessible through the service accounts. So you need some kind of limiting the access or auditing at least who is accessing what resources. Okay, it's pretty important for the application design. In the same way, if you are administrator, you need to be focused on who is accessing the nodes, who has access, who can access it onto the nodes. So these are the cluster environment aspects which you need to be careful in terms of security or best practices. There are certain things as an application developers view also you need to be careful, and from the cluster administration point of view also. So till that we discussed about the normal container best practices and the Kubernetes best practices. Let's look onto some application design and architecture point of view. First thing, always design per process per container. What it means is there are a lot of process you may run in terms. So for example, if you guys are using RabbitMQ or any kind of message broker, if anyone has access, there are TCP ports, plus also there are management ports. Don't run multiple process as part of single container. If you have multiple process, try to run it into multiple containers, because pod is something designed for the same reasons. So in the pod you can run multiple containers that can share the same network space, IPs, and also the storage. So for in case of multiple processes, always use multiple containers pods. Labels and selectors. So if you know about the pod deployment services, how they access each other, it always goes through the label and selectors. Labels and selectors are pretty much powerful functionality when it comes to a large clusters. You can create the labels and selectors around different services, around different application layers, around different application environments, different build process, maybe at the node levels, maybe at the machine type level. So when it comes when it comes to very large cluster, you can basically utilize this. You need to tune these labels and selectors carefully. Always follow list privilege principle. I guess we all understand this aspect pretty well. Don't focus on application restart in case of failure. Instead, focus on the crashing it clean. We already discussed this. Okay. Don't use the service type equal to load balancer blindly. Okay, in most cases, increase is good enough. So let's try to understand the load balancer, what it does. Service type equal to load balancer. Whenever you apply this into a cloud environment, it basically uses the cloud load balancers. There's certain cost involved on that. Think about the microservice environment. You have multiple services are running, and for each services you are using service type equal to load balancer. In that cases, you will end up with using multiple cloud load balancers, and each one associate the cost on that. You definitely don't want to do this. Can we save the cost on that? Best case is use the ingress. It provides internal routing for different services and expose a single endpoint. Of course, ingress is a L7 type. L7 means layer 7 type protocol. So if you are using the HTTP load balancer, then ingress is good. If you have network load balancer L4 type, you still need to use service type load balancer. Init containers. Init containers are something for bootstrapping purpose. So what happens? Look from the normal container point of view. These containers are normally running process. Okay, you can also use the sidecar design pattern. I'll share a link of. I mentioned a link after this slide where it's different design patterns been mentioned. On that sidecar is also there, so you can explore that. So in sidecar design pattern, what happens? You have a main container which is running, and if you basically want some kind of virtual functionality, proxy functionality, you can put it into sidecar containers. So it's inside a single pod, you are running two containers. One is main container, and another one is sidecar container. But when you look from the sidecar container, this is mainly used for the running process, like proxy. It's always running, always intercepting. But init containers are something like for the initialization purpose. Okay? That's mostly run for one time. So don't use the sidecar container for initializing the containers. Instead of that, there is always a function. There is a functionality called init containers. Use that for bootstrapping purpose. Use the record option for easier rollbacks. So there are self-explanatory. You can just go into rollbacks. It will be, you can explore that. Whenever you are creating the container images, don't use the latest or without tag. Always use the proper versioning on the images. Okay. Always use deployments instead of bare pods. So what happens in deployments is, suppose deployment is accessing three pods. Okay, you create a deployment with three pods. It's running perfectly. Now, if you create a single pod, apart from deployment, just bare pod you create with the same label selector, it will still be accessible through the deployments, because deployment picks the pod based on the label and selectors. Okay. Also, if whatever bare pod you created, if you just stop it, it's stopped. But what happens in deployment case? If you stop a one pod, deployment will identify, okay, this pod is stopped. So currently there are two pods running, but expected is three, so it will start in the thread, another pod. So always create the pods through the deployment, not the bare process. Here I mentioned the multi-container pod design patterns. So there are different design patterns when to choose multi-container pods. In normal scenarios, single container pod is more than enough, but in certain cases, it's required. So for example, if you guys know about the Istio uses the sidecar pattern for the proxy, for envoy proxy. So this is general application design principles. Few things you need to look for. Suppose you are using the cloud or managed Kubernetes platform. They generally provide regional and zonal clusters. It's basically a cloud concept. So in the cloud, if you are creating an application, high available application, in that case, the best practice says it should be spread across the zones. Now, when you come into zonal clusters, whenever you create a cluster in terms of zonal cluster, you basically select the region of particular zone and you just create a cluster. So as part of cloud best practices, it's not a high available situation. So if you want a high level cluster, you can always prefer to go for regional clusters, which will span across different zones. Look for the service mesh like Istio. I already explained you what Istio does. In general, Istio provides three to more four important features. One is basically traffic splitting. So think about a scenario like A/B testing, blueprint deployments. It's pretty much useful. Suppose you have one global application and you want to basically launch a new feature just for a specific set of area, or specific set of basically you can say only for mobile applications. So in that cases, Istio is pretty good. It basically provides the traffic splitting across different versions of the services. It also provides the authentication authorization at the network level, which is basically you can think of the extended form of network policy in Kubernetes. And third is observability and traceability, which it provides. So it basically provides some extendable framework. It integrates with different solutions, either Stackdriver or Prometheus, so on. It passes the all the observabilities like metrics, etc., to them, and you can use that. So if you guys are using microservice environments, it's always recommended to use service mesh. Look for the managed Kubernetes platform features. So as of now, I'll talk on just one managed platform. Let's look from the Kubernetes GKE point of view, um, Google Kubernetes Engine. But similar kind of principle, if you guys are in other clouds, you can apply the same. So we understand the Kubernetes, what it provides. It provides the scheduling of pods, it provides the scaling of application of pods. Okay, it provides the auto healing capability, but this all is in the application level. It doesn't provide these features at the node level. So if your node is down, Kubernetes by default it doesn't restart the node or create a new. If you want to scale the cluster, Kubernetes doesn't provide it. That is the exact thing which managed Kubernetes platforms provide. This is basically one of the feature, not all. So if you go on to GKE, you create a cluster and just stop the one node. You will see that it will basically restart the new nodes if your self-healing capabilities is basically checked on. It's enabled then. It also provides the auto scaling of the cluster. So always whenever you are choosing the platform, either I'll have to create my own cluster, or that I'll have to use some open source tools like Kops, etc., for creating the Kubernetes cluster, or I'll have to use the managed Kubernetes platforms. Just look for their features, what managed Kubernetes platforms providing. Okay. Then you can also use some CNCF related projects like Flondi, Open Tracing, Prometheus, etc. Flondi is basically using for centralized logging. Open Tracing and Prometheus. Open Tracing is basically about the traceability on different level, and Prometheus is more like metrics and alert management, monitoring, so on. So when you are looking from the enterprise point of view, when you are looking from the design point of view, these CNCF projects are pretty useful. That's it from my side. There's one aspects I didn't cover, that is the security aspects. So there are few security aspects we covered, but there are more than that. So for example, you will be defining the RBAC. We didn't discuss in detail the RBAC, resource quota, network policies, pod security policies, authorization policies, and so on. When you are looking from the administration point of view, you'll have to basically careful about this thing. They provide a lot of internal features, a lot of configurations, which is pretty important for tuning the cluster. Okay, let's go on to the question if you guys have anything. Oh man, sorry. Sorry guys, I don't know why the screen sharing has been stopped, but let me share the slide share link. You guys can just go through that. Can you please look onto this link? You will get the PPT. Let's go through the questions if there is anything. Is there any option to specify pod ready news status in YAML? I didn't identify the question. What do you mean by pod ready news status? Can you give more information on that? Uh, DevOps engineers Linux. Because I'm not able to understand the question. It's better if you guys can give a little bit more information on this. Otherwise, just message me the a little bit detailed question on the meetup.com. I'll try to answer this question. Other question from Shashidhar is how to percentage issues gracefully when pods are getting started in different nodes. Okay, so for the persistent, you need to be look from three different perspectives where you want to store the data. Do you want to store the data at the pod level in terms of caching? Do you want to store at the node level, or do you want to store it outside of cluster so you can access always if your pods are moving across different nodes? Okay, it's always useful if you are using some kind of persistent. You want your data to be persistent. It's always useful to use volumes out of clusters. So, for example, if you are in the Google Cloud, let's assume you are using the GK cluster. On that case, you can use the persistent disk as the mm, outside of your VMs and just attach it to that. So whenever your pod is moving, even if your node is down, your data is safe and you can reattach it. Okay. But if you have some kind of caching data, which is not very much important, you guys can use different node level or the pod level also. You can look for some other PPT on the mm, on my SlideShare link. I'll share it that we discussed this on the last meetup, how to basically handle the persistence on different situations and handle it gracefully. So if I answered your question, that's great. If not, just message me. I'll send you the PPT link, or you can also see it on the SlideShare link. Other question is any good site to start the Kubernetes cluster? If you just want to play with the Kubernetes cluster, I guess there is Katacoda, which you can just use it for the just training perspective, like just you just want to do hands-on. Otherwise, you can. It depends where you want to run. If you just want to run in your local laptop, you can just use Minikube, which is a single node cluster, which is also not chargeable like anything. It's open. Only thing is if you are going for enterprise or real-time use cases, just go for some managed solutions. That's a good start because it will reduce a lot of cluster creation aspects. As application developer, you don't need to worry. Any other question? Okay, guys, I guess we have done with this. In case you guys have any questions, just message me on the meetup.com. I'll answer it as soon as possible. Thank you. Thank you, everyone.